Now let us see the sign convention for spherical mirror. New Cartesian sign convention is used for measuring various distances. Hello friends, today we are going to discuss the rules for obtaining images formed by spherical mirrors. There are two types of spherical mirrors, concave mirror and convex mirrors. So let us first discuss the rules for concave mirror. These rules are very important because whenever an object is placed in front of the concave mirror, an image is formed. Image is formed only when two reflected rays actually meet or appear to meet. The following rays of light are usually used to locate the images formed by spherical mirrors. So rule 1 says us that if an incident light is parallel to the principal axis, you can see this is the principal axis and this is the direction of incident light. If the incident ray of light is parallel to the principal axis, then the reflected ray passes through the focus. This is rule 1. And rule 2 is when an incident ray of light, this is the incident ray, this arrow mark pointing towards the mirror is the incident ray. The incident ray of light which passes through the center of curvature retraces its own path. That means after reflection it travels along its own path. So this arrow mark tells you that reflection is taking place along the same path. Coming to the third rule, according to this rule, when an incident ray of light passes through the focus of concave mirror, after reflection the reflected ray is parallel to the principal axis. So this is the reflected ray. The last rule is incident ray of light, when it is incident at the pole, after reflection it makes the same angle with the principal axis. That means I will be equal to R. Now coming to the rules of convex mirror. In this case, when the incident ray of light is parallel to the principal axis, it passes through the focus. It is not actually passing, but when you extend this reflected ray backwards, it looks as if it is passing through the focus. So this we call as appear to pass, but it is not actually passing. Next thing is, next rule is when the incident ray passes through the center of curvature, it retraces its own path. In this case also, it's not actually passing through the center of curvature, but when we extend this line backwards, it appears as if it is passing through the center of curvature. Then the third rule is when the incident ray passes through the focus, you can see this line, it's passing through the focus, it appears to pass through the focus. After touching the mirror, it gets reflected and this reflected ray is parallel to the principal axis. Rule 4, when this ray, incident ray, is incident at the pole, after reflection, the reflected ray makes an angle with the principal axis which is equal to the angle of incidence. So I is equals to R. So by this we end our topic. Now let us see the sign convention for spherical mirror. New Cartesian sign convention is used for measuring various distances in the ray diagram of spherical mirrors. We have 5 sign conventions. According to this, first one tells us that all the distances, if we want to measure the object distance, whether it is placed in front of, how far it is placed in front of concave mirror, if you want to measure that, the distances should be measured from pole of the spherical mirror. So you should start your scale from here, 1, 2, 3, whatever number you get. So all the distances should be measured from the pole. That is the first rule. The second one is the distances measured in the same direction as that of incident light is taken as positive. So in this case here, we have, you can see, if our image is formed somewhere here, then we keep our scale here at the pole number 1 and then we start measuring it. 1, 2, 3, whatever is our scale. Then 5 centimeter. You can see this direction here and the incident light direction is same. So if we have a direction same as that of incident light, then we get a positive sign. You can see here, if the distances are measured in the direction of incident light, then that distance is called as positive distance. And the second thing is, the next rule is, if the distances are measured against, here same and the third one is against. If the distances are measured against the direction of incident light, then we write it as negative. Against the direction of incident light, negative distance. So you can see this arrow and this arrow, they are against. Okay, next thing is distance is measured upward. If we want to measure the height of the object, this is the arrow mark we use. If the distance is measured upward and perpendicular to the principal axis, then that distance is called as positive distance. If the distances are measured downward and below the principal axis, that height is called as negative height, or negative, we get a negative sign for that number, 5 centimeter or something. By this we end our topic.